What's up guys, and welcome to the 9th video in the C# tutorial series. So this video is going to concentrate on enumerations in C#. Alright, and what enumerations are is they allow values with integer values to have string literals, and this allows for type safety and just some cleaner programming for the programmers. Okay, so they are really helpful when you have so that you can actually classify and categorize into a certain category, and then be able to assign an enum to it, all right, and then easily be able to distinguish between the different values. Okay, so if you haven't messed with the enums, then here's how to do it. If you have, then just here's how to do it in C#. So let's go ahead and start a project, a console project, and we'll just call it enums. And we're gonna follow the same example of the card, example that we've been using in the last few videos, just to relate to it a little more. So the way you can actually create a enum is with the enum keyword. So you can do public enum, and then we can have an enum called cards, and then inside of this is where you actually specify your different ones. Okay, so we're going to get into this right now, but I think a good way to see how something is useful is to first not to use it, and then that way you can be able to see when we do use it why it's so useful. Okay, so let's go ahead and make a method. All right, and what if we had a method called return value? Say return, we'll have it return the int, and then we'll call it return value of card. All right, and then it took in a certain value, of course. So it returned, and it took in the card. All right, so imagine that this obviously would be as simple as return card, but imagine if the card value isn't the same as the card you're returning. So you assign, say, 0 to the 2 card, so you have to say, okay, it's a 2 card, return 2, the actual value. All right, so you basically have a key and a value. So essentially, say if we did have that, what we would probably use is like a switch case, in which we would have different cases, of course, for that, and we would have case 0 would be, and then that would be like the first card. Then we'd say, okay, we return 2, and then of course 1. This would be like the 3 card, case 2, return the 4 card, and so on. So you kind of, hopefully it's hard to see the resemblance between these cases. You're just mapping, you get the key of it, which is 0, 1, 2 in this case, and then you simply just take that and then return the actual value. Okay, so sorry, we don't actually need the breaks because we are returning the value, so that's kind of like acting like the break for us. All right, and then of course we'll need like a default value, so you just would return, say, 0. All right, so now you would call upon this inside of your method, inside of your static void main method, and then you would say return the value of a card with the key of 1. It would come into here, of course, and then return the 3 card. So that would be an example of what you would need to do if you had a key value, which is sort of what an enum is. You have a key that's a string literal, and then you simply return that value. So sometimes this could be hard to read because you wouldn't know, well, what's 0? What's 1? What's 2? So what are these values? When you come back to them, months later, weeks later, and you forget what these values are, you'll have to, of course, comment them and say 0 is the 2 card. And then, of course, you can just read the code and then, eventually figure it out. But you may have some really complex code to where you're relying on these values and you forget what these values are. And that's where enums come really into play. And one of the great things about them is the fact that you can now read them like a string literal, but it's actually behind the scenes still an integer. So what do I mean by that? Well, what I mean is you could have your cards, and then each one you're going to have your cards. So you can have a 2, you have your 3, you have your 4, you have your 5, 6 card, 7 card, 8 card, 9 card, 10, Jack, Queen, King, and then of course the ace. So now we have these cards, right? And then if you don't define any kind of value for them, what C# will do is infer it. So this will be 0, 1, 2, 3, 4. So these will actually be the values of them behind the scenes. So what do I mean by that? Well, what I mean by that is, let's go ahead and print one out, and let's make a card. So we'll do read line to make sure that pauses. So let's come up here, and let's create a card enum. So we'll do cards, card equal cards dot, and then here in the IntelliSense, all of my available cards come up. So say I want to pick the 10 card, all right? And then now let's go ahead and print that out to the console. So we'll do console.writeLine. And what you might think is 10 will show up, but 10 will not print out. What's actually going to print out is 0, 1, 2, 3, 4, 5, 6, 7, 8. So the 8 is going to print out because it starts at a 0 index. Show you what I mean by that. Oh yeah, I'm sorry. So if you actually print out the integer value, of course, you need to do that. Then we have our 8. So our 8 will print out because the underlying value of our card is 8. And we don't ever really mess with the 8. All we ever really do is we use this value, and this is the value that we actually see because it's a lot more readable and it's just easier to work with, right? And all I'm doing is right here I did a cast, and I casted it to its true integer value, and I forced C# to show me the actual underlying value rather than the value that we work with. And of course, if you print this out like you saw before, we have 10, and that's what we expect, okay? So let's just stay with that for now. Let's just accept that C# will give us 0, 1, 2, 3, and so on values for these values that we have given it, okay? So let's come back to an example where we have 0, 1, 2. Let's come back to here, and we'll now it's going to take in a card. So here we know that it's going to actually take in a card value. And then now what we can do, we'll start getting some errors because it doesn't know what to do. And this is a card. What we're actually going to be able to do now is do cards dot, and then we can handle the events here. So 2. And remember, this was the 3 card, cards dot 3. This was the 4 card, cards dot 4. And then there you go. So what we could do now is we could have a joker value. And in our default case, we don't know what it is, so we'll just assume it's the joker. So we'll do return cards dot joker, and then we can cast it to its true value of an int. All right, so that'll work just perfectly. And now what we get out of this, guys, is what we get out of it is that the fact that we can easily read it now. We can say, okay, 2 card, oh, 3 card, 4 card. It becomes really obvious what the programmer, whether you wrote it or not, is doing in the switch case and what these cards mean. We don't have to look them up and see what these values are. We could just say, oh, that's the 2 card, that's the 3 card, that's the 4 card. And we can easily see, and it's a lot more readable than what we had before, which was just 0, 1, and 2. All right? So there you have it, and then that's a really good example of when to use the enum for our cards. So, but what if we want to give it an actual value of a meaningful value? Remember that when we printed this out, its actual underlying value of an integer, we got 8, and that's because, like I said, it starts at the 0 index. But what if we actually want to give it a value that is meaningful and actually makes sense? Because remember, in blackjack, the card game that we were dealing with the last video, 10 actually has a value of 10. And then 9 actually has a value of 9. So wouldn't it be nice that the underlying values that that C# infers for are those actual values, so that we don't have to really worry about printing it out, or we can actually check against those values? And the way you can do that now is actually just force it to be equal to a certain integer. And that's just, really convenient. So now we can come over here get rid of that right there. Now we can come over here and see that it is 10, and we don't have to do the rest of it actually, because if we force C# to start at 2 instead of 0, it'll say, okay, I'll start at 2 as my offset, and then 3, 4, 5, 6, 7, 8, 9, 10, and then there you go. So now all of these, but this one's going to be 10, and then this will be 11 and 12. So what we need to do is make sure that these values are all the same. And then of course we'll make this 11, but if it's 1, we'll deal with that. All right. So we'll do, and notice that when we print out any of these, whether it's a jack, a queen, a king, we'll see that it's printing out 10 because all of these are forced to be 10. And that makes sense for the game of blackjack because a face card is going to be, you know, the jack, the queen, the king, and the 10 are all going to have the value of 10 in the game of blackjack. So in this case, that does make sense. So now we have a readable code, and now what we can do is easily be able to just see what's going on at the blink of an eye. And now that we have these underlining values that are actually the true values, what we could do is instead of saying have a hard set value of 2, what we could do now is we can actually just do away with the switch card entirely, because all we have to do now is simply do return int card, and we will get the correct value from here, as long as these values that are initialized are true. Okay. And the reason why, guys, if that's not very apparent, is because all we're doing here, if we do that, all we do here is we're doing, okay, return int card, because we know that when it's 2, this value is actually 2. And then we can come into here and say, okay, we'll return int card. And then here we'll do return int card. So, I mean, you know, you'll start to notice a little pattern of, well, we're doing the same thing over and over again, right? You know, for whatever card we have, we're returning the true value of it. So wait a minute, we could just do away with this, right? And that's what I did just a few moments ago, is return the actual value of the card. And so that gives us the value when we actually want the value of the card. All right. So now this whole method has become a little redundant because of the fact that we've already taken care of everything here. So we don't need to call upon this method. We never have, of course. We were just using an example. But why call upon the method card when all it returns is this? And it really doesn't do much logic, except if you have a getter or a setter, of course, if you wanted to do that. But now all we need to do is we're already doing that here. All right. So if you don't want to do that here, you could still keep this method, and you know, where it always just casts it, and you don't want to do any casting anywhere else, then that's fine. That's up to you as a programmer. But now you can do, we would be able to do now return value of card, send it a value of card type, and then it'll simply just output that. All right. So when to use this, now you know how to use it, but when to use it, you know, sometimes that's even more important. Is, okay, I know how to use something, but when are you ever going to use it if you don't know why, right? You don't really know why or when to use it. The how is sort of meaningless at that point. So, you know, if you find yourself doing something like having a lot of integers like public const, which is the way that it's constant, so it can't change after it's initialized. And then you can do public const, and then you can do something like, you know, usually it's in caps, so you'll do like 2 card equals 2, and then public const 3 card underscore 3, or card equals 3, and of course we could do const, have to replace that with the ints, and then so, you know, doing something like this, if you notice yourself doing something like this, then it's time to start switching over to an enum, because the fact that, you know, this is fine and dandy, this is, you know, nothing wrong with this, but then you're going to have that method where you pass in an integer, because that's what this is, and then you'll have something like int and then you will have to use that switch case card, and then you'll have, you could just do return card, which doesn't really make sense. But at some point, when you're using this a lot, you're not really going to know what a 2 card, a 3 card is if you're like, somewhere else in the code in a really, really long 1,000-line class or something. It's really helpful to know what a card value is, and then you can come over here, and then you don't get any IntelliSense. I mean, that's just, IntelliSense is always nice because now we can do cards dot, and then we don't have to remember, oh, 0 or 1. Oh, we can just do cards dot Joker, and that'll give us the Joker value. So it's really helpful because we don't have to remember, 4 card, 3 card. Of course, we have these values here, but really they're just plain old integers that we can work with. So, which these are 2 underlining integers, but they give us a string literal to just make it, read only and a little bit more with a little more type safety. So, when you find yourself doing that a lot, just erased it, then, it's always nice to switch over to an enum and be on your way with that, because it's just a little cleaner way to do it. But remember that enums are they just have integer values, underlining integer values. However, you could specify a different value, which is like a byte. Say that's an approved type for an enum is a byte in C#. So then you can do something like equals, and this is of course in bytes just two hex values, right? So that's a byte, but that would be more, so it can't hold that. And this is all base 16, so but you can still just choose 09, and that'll be perfectly legal as long as I put that comma. So something like that. And some other supported values I know are like long, where if you need to hold a larger value, here you don't have to actually specify int. It'll just infer that that's what you're actually doing as the underlining value. But most of the time, integers are just going to be the way to go. So there you have it, guys. I mean, now with that, we're going to definitely be using some form of this in the later tutorials with just weightings to make it a little cleaner on you guys and see that, when you come back to it, you can be able to see what I'm doing, and it should be a lot cleaner since you don't have to remember any of the values. You can just look at this and trust that 2 is a 2 value, and then jack and all those cards above are all 10 values, and then so on. So there you go, guys. Now in the next video, we're going to be taking a look at some arrays finally, and arrays will be perfect for what we're doing with the card example, because of the fact that it's our first data structure that we're working with, and therefore we can represent a deck of cards with our array, and with that we'll be able to make a little bit more robust game in the future. All right, so thanks for watching, guys.